Hey everyone, and welcome back to Backend Decoded. Today's problem sounds like kids for kids, but the insight inside it, that's pure interview thinking. We have a bunch of kids with each with some candies. We have extra to give, but only to one kid. The question for each kid, would giving them everything make them the richest in the group? Simple setup, clean solution. Let's go. Let me show you visually. You are given an integer array candies where candies of I represent the number of candies the ith kid has, and an integer extra candies denoting the number of extra candies that you have. We basically need to return a boolean array result of length n where result of I is true if after giving the ith kid all the extra candies they will have the greatest number of candies among all the kids, or false otherwise. Note that the multiple kids can have the greatest number of candies. Okay, so based on the given array, let's check what is the max candies any kid can have in this. Okay, so the array is basically 2 3 5 1 3. Okay, so among these the second kid is holding the max number of candies, right, which is 5. Okay, now let's start giving each kid the extra candies that we have, and let's check if how many of them can have the greatest of candies among themselves after giving the extra candies. Okay, let's start with kid 0. Okay, kid 0 is already holding the 2 candies, then after giving the 3 extra candies then he will have the 5 candies, right? So if you compare it with the max candies from the array, uh, the condition satisfies, right? The kid 0 can have the maximum number of candies among themselves after giving the extra candies, which is 5. So we basically need to return true here. Okay, then let's do this for each of the kid. Okay, so now kid first is holding the 3 candies, and after giving the 3 extra candies then it will have 6 candies, right? So 6 is also greater than the max 5 candies, so we need to return the true. Now the second kid is already holding 5 candies, and after giving 3 will now have 8 candies, so we also need to return the true in this case too. Now the third kid is having just one candy. Okay, and now after giving the 3 candies it is having 4 candies. So if you look at here, even if we give the extra candies to kid 3, it it can max have the 4 candies, which is basically less than the maximum present in the existing candies array, right, which was 5, right? So in this case we need to return the false. Okay, now let's do it for the kid 4. Kid 4 is holding 3 candies, then 3 plus extra 3 is equal to 6. So in this case also we need to return the true, right? So in this case, yeah, only the kid 4 can't kid 3 can't make it, even if we give the extra candies to that kid. Okay, so what will be the output here? It is true, 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 then false, and last is also true, right? Now let's make it formal. Result of I is true when candies of I plus extra candies greater than or equal to max, right? And result of I is false otherwise. We don't simulate anything, we find the max ones, then check every kid against it. So let's write the algo. So step 1 is find max, which is time complexity of this is order of n. Step 2 is check for each kid. Check for each kid, and the time complexity of that step is also order of n, right? So total time complexity here is order of n, done, right? No sorting, no nested loops. The brute force is the optimal solution. Recognizing that immediately is the skill. Now let's write the code. We are given a function signature func kids with candies, and it has two parameters. First is array of integer candies and extra candies, which is int. We basically need to return array of bull, right? So we'll take one variable to find the max, then we iterate on candies, then okay, if c is greater than max, then max will be c, right? Simple loop to find the max. Then our result array, which is basically array of boolean, so use the make to initialize the that array. And then the length of that array will be the length of candies, right? Now iterate again on the candies array. Okay, so result of I will be c plus extra candies greater than or equal to max, right? And then simply return the result here. That single line, result of I is equal to c plus extra candies greater than or equal to max. No if statement needed. Go evaluates and store the boolean directly clean. Okay, now simply run this code. L1431. Okay, okay, we need to write the actual main function to execute this function and call the function. Okay, so we need to pass an array. So let's take the example given on LeetCode 2 3 5 1 3, and the extra candies are 3 basically. Okay, okay, so if you can see, we got the proper result: true, 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 false, true. That's what we have already seen, the expected output: true to true, false true, right? Okay, now let's move on to our next section, which is how you can explain this in an interview. So here is your interview script. I find the max in one pass. Then for each kid, I check if their candies plus extra reaches that max. Results stored as a boolean directly. Order of n, time complexity, and order of n, space complexity. Okay, short, structured, and confident. Now let's go through the edge cases. If all equal candies, then everyone will be true. If extra candy is equal to 0, then only current max kid are true. Single kid always true, right? One condition covers all of them, no special casing needed. Let's talk about the complexity. Time complexity here is order of n, because we are only iterating once on an array to find max and once to calculate the result, right? And order of n, space complexity, as we are using the extra boolean array. Okay, so we must visit every kid at least once. This is already optimal. Simple is right here. Easy problem tests speed of clarity, not complexity of thinking. Find the key variable, express the condition cleanly, explain in 30 seconds. That's what easy problems are actually measuring. Practice explaining this out loud. See you in the next one.